Ever wonder what's really happening when a PyTorch model learns? It's a bit like magic, right? Today, we're pulling back the curtain on the engine that drives it all, the training loop.
And you don't need to be a coding wizard to get it, no sorry.
Yeah.
We're diving deep into the why behind the code. Thanks to a fantastic guide by Daniel Voigt-Godoy called Deep Learning with PyTorch Step-by-Step, he breaks down practical coding in a way that just clicks.
Godoy's approach is perfect for us, hands-on but crystal clear. So let's talk about this training loop. It sounds kind of mysterious, like a secret ritual for our PyTorch models.
Think of it as a cycle, a constant process of learning and improving. It's how a model goes from zero to hero, making intelligent predictions.
Okay, I'm intrigued. What are the steps in this cycle of learning?
There are 4 key steps that happen within each loop: the forward pass, loss calculation, backpropagation, and parameter update.
Wow.
Each step is like a cog in a well-oiled machine, working together to refine the model's understanding. It's actually quite elegant when you think about it.
Okay, break it down for me. Let's start with forward pass. It sounds like our model's making a bold move.
It is. In the forward pass, the model takes our input data and, using what it knows so far, makes a prediction. It's taking its best shot, so to speak.
So like a basketball player taking a shot, they're aiming for the hoop, getting closer with practice, but might not always make it at first.
That's a great analogy. Now, just like a coach would analyze a missed shot, in the next step, loss calculation, we figure out how far off the model's prediction was.
Right, we're quantifying the error. But more importantly, how do we help the model learn from these misses?
That's where backpropagation comes in. The model takes that calculated loss and essentially figures out, okay, where did I go wrong? How do I need to adjust my inner workings, my parameters, to do better next time?
So it's like the model is doing its own self-assessment after each attempt, figuring out how to adjust its strategy for next time. That's pretty cool.
Exactly. And finally, we have the parameter update. Based on the insights from backpropagation, we actually adjust those model parameters, guiding it toward better predictions. This is where the learning rate comes in. We're carefully nudging the model in the right direction.
And I'm guessing the optimizer plays a role in this fine-tuning process, right?
Right. The optimizer determines the best way to make those parameter adjustments, making the learning process as efficient as possible.
So we've got this 4-step cycle: forward pass, loss calculation, backpropagation, parameter update. It seems like it could get repetitive, writing out that same code every single time we train a model.
You're reading my mind. That's where the beauty of higher order functions comes into play. Godoy shows us how to streamline this by creating a make train step function.
Higher order functions? No, those always sound a bit intimidating. Can you give me a simpler way to wrap my head around them?
Absolutely. Imagine a function that can create other functions tailored to specific tasks. That's a higher order function. In a nutshell, it's like a function building function.
Okay, that makes sense. So we're basically pre-packaging that entire 4-step training process into one neat function.
Precisely. It helps us avoid writing redundant code and keeps things nice and organized.
Streamlining for the win. But even with a well-oiled training loop, we still need to consider the data itself. And in deep learning, we're often dealing with massive amounts of data. How does PyTorch help us manage that without our computers bursting into flames?
That's where datasets and data loaders come in. They're the dynamic duo of data handling in PyTorch, making sure things run smoothly, even with huge datasets.
Data handling sounds very official. Break it down for me. What are datasets and data loaders in simpler terms?
Imagine a giant cookbook filled with recipes. That's your dataset. It's how your data is organized. Now imagine a chef who takes that cookbook and serves you manageable portions, ready to eat. That's your data loader. It takes your data and preps it into bite-sized batches for your model to learn from.
So instead of trying to eat the entire cookbook at once, the model gets digestible portions. That makes a lot of sense, especially with large data sets. But why is this batch idea so important?
It's more efficient for the model to learn in smaller, more frequent steps. That's called mini-batch gradient descent. It's like taking the stairs instead of trying to jump over the entire building in one go.
Okay, I can definitely see the benefit in that. It makes the whole process feel more manageable.
Exactly. And there's another cool thing about data loaders. We can tell them to shuffle our data before serving it up to the model. We do this by setting shuffle. Sure.
Is that like shuffling a deck of cards so the model doesn't memorize the order of the data?
You got it. Shuffling helps the model learn the underlying patterns in the data, not just the order it happens to be in. This is crucial for making sure our model can handle new data it's never seen before.
So we have our training loop, our data nicely organized into batches and shuffled for good measure. But how do we know if our model is actually learning and improving? It feels like we need a progress report.
You're absolutely right. We need a way to track our model's progress and make sure it's not just, memorizing the answers. That's where evaluation comes in.
Ah, evaluation the model's report card.
Hmm.
But we don't want our models to just be good at memorizing, right? We want them to actually understand and generalize.
Exactly. We don't want our model to just ace a multiple choice test because it memorized the answers. We want it to understand the concepts well enough to tackle an essay question, something it hasn't seen before.
I like that. So how do we make sure our models are really getting it and not just cramming for the test?
We do this by testing our model on a separate set of data that it hasn't seen during training the validation set. This gives us a much better idea of how our model would perform in the real world with brand new information.
So it's like a pop quiz to assess true understanding, not just memorization. Clever. And you mentioned model.eva earlier. Does this come into play during evaluation?
Absolutely. It's a small but crucial detail. Remember those parts of our model that act differently during training to make it more adaptable? Well, model.eval tells those parts to behave optimally for making predictions. It's like telling our model, okay, showtime, time to use everything you've learned.
Switching from learning mode to performance mode, I love it. And to make sure this evaluation is super efficient, Godoy introduces another handy tool, torch.integrad.
You got a sharp eye.
Yeah.
During evaluation, we don't need to calculate those gradients anymore because we're not updating the model's parameters. Torch.integrad tells PyTorch to skip those calculations, saving us time and memory.
So we're streamlining the evaluation process. It's all about working smarter, not harder. And speaking of streamlining, let's talk about those higher order functions again. Godoy has another one up his sleeve, the mini batch function. What's its superpower?
This function takes our data handling to the next level. Instead of manually coding how to process each batch of data, the mini batch function takes care of the entire workflow. It's like having a personal assistant to handle all the tedious details for you.
Talk about delegation. That's my kind of function. Tell it what to do, and it just makes it happen. What do we need to feed this function to get it going?
We give it three things: the device we're using, our data loader to serve up those batches of data, and our trusty train step function. With those three ingredients, the mini batch function orchestrates the entire mini batch training process for us.
Wow, it's like conducting an orchestra. Just tell the musicians, the functions, what to do, and they create a symphony of efficient training. This is making me feel so much more organized about my PyTorch code.
I'm glad to hear that. Organization and clarity are key in deep learning. Now, speaking of clarity, there's one more crucial detail that Godoy emphasizes: always setting the correct mode for our model, whether we're training or evaluating.
You're right, we've touched upon model.eval, but it seems like setting the right mode is so fundamental that it deserves a dedicated spotlight. Why can't our model just be in a permanent state of readiness?
It's like the difference between, let's say, practice and game day. During training, our model needs the freedom to experiment and learn from its mistakes. But when it's time for evaluation or real-world use, we want it to be laser-focused on performance.
So setting the correct mode is like giving our model a pep talk and setting the stage for success. It's amazing how these subtle tweaks, like setting the mode, can make such a big difference in how our model performs. Speaking of performance, we've been talking about training these powerful models, but what happens when it's time to actually use them? It's like we've baked this incredible cake, but how do we save it for later? We don't have to rebake it every time, right?
That's a great analogy. And you're
Sure.
absolutely right. We don't want to start from scratch every time. Luckily, PyTorch makes it super easy to save and load our models so we can pick up right where we left off, or even share our trained models with others.
Okay, that makes a lot of sense. It's like hitting save in a video game so you don't have to replay the entire level again. But it's not just about saving our progress, right? What are some other reasons why saving and loading models would be a game changer?
Think about collaborating with other developers, deploying your model into a real-world application, or even just coming back to your project after a few weeks. Being able to save and load your model gives you so much flexibility and portability.
It's like having a pause button for your deep learning projects. So how do we actually do this saving and loading in PyTorch? Is it as simple as clicking Save As?
It's almost that easy. PyTorch uses the torch.save function to capture the essence of our trained model, all those fine-tuned parameters, and store them safely in a file.
So we're basically bottling up all that hard-earned knowledge. How do we decide what to include in this knowledge bottle?
We usually create a dictionary that holds the model's stata dict, which contains all those precious parameters. And if we want to be able to resume training from exactly where we left off, we also include the optimizer state edict.
It's like saving the entire state of our training session. And then when we're ready to use this saved model, loading it back into PyTorch is just as straightforward, right?
Exactly. We use torch.load to retrieve our saved model file, and depending on what we want to do, resume training or make predictions, we load either the full training state or just the model's parameters.
So it's like choosing whether to reheat the entire meal or just grab a slice of cake from the fridge. And speaking of serving up those delicious predictions, we need to make sure our model is in the right mode. It's model.eval.
Time again right.
You know it. Setting model.eval before using our loaded model for prediction is crucial. We want to make sure those dropout layers and other training-specific behaviors are deactivated, and our model is primed for delivering accurate predictions.
It's incredible how much we've covered in this deep dive into the PyTorch training loop. We've gone from understanding the individual steps of the training process to managing huge data sets, visualizing our progress, and even saving and loading our trained models. We've really demystified the entire process. And remember, the beauty of PyTorch is that it's so well designed and user-friendly. Once you grasp these core concepts, you'll be amazed at what you can achieve.
You've given us so much to think about today. So to our listeners, remember, understanding the training loop is like having the keys to the kingdom. It's the foundation for building powerful and effective deep learning models. Keep experimenting, keep learning, and most importantly, keep asking those why questions. Until next time, happy training.